Hi guys, I hope you are fine. Me too, I'm fine. So guys, I come before you with yet another lesson on derivative from first principles. And so guys, we are going to do these problems and let's see what we shall get. So I read the question first. Given the following, find dy dx from the first principle. So these are the problems. So guys, the first thing we shall do is to write the equation required. That is the general formula for the first principle. That is derivative from first principle, the formula that is used. And here are our formulas, guys. So we have f prime x, that is the derivative of x from the first principle, is given by limit as h tends to 0. This one comes to f x plus h, like that, minus f of x all over h. So we use that one, and we can also use another one, but let me first of all use this one for these equations. But for the last one, we shall use the other one. But as of now, let's first of all attempt the first question. So using this equation, guys, we shall come and write here, using this equation, where there is x, for that one we shall add plus h for the first function. So that now we shall have x plus h minus 1, x plus h plus 2. And so this is how we do it. Shall come here and write f of x is equals to limit h tends to 0. I now come to this question now and write x. After writing x, just as I have written plus h, I'll come and write plus h. Now minus 1. Then I come to this other one, I'll write still the same. X plus h plus 2. Like that. So from there, I am supposed to take away. I put minus sign, I write fx, meaning that I'll just write it the way it was formerly, without addition of h, meaning that I'll just write it the way it is here. So I'll come and write x plus x minus 1 all over x plus 2, like that. And then guys, we have all over h, so I'll put this one, the all of it all over h. So that's how, guys, I'm going to deal with that question. So guys, let me first of all deal with the numerator. So for the numerator, I will look for the LCM of that. Let me just write it here. You will have x plus h minus 1 all over x plus h plus 2 minus x minus 1 all over x plus 2. So guys, we come here and look for the LCM for that. So the LCM for that, guys, we can take both of these values. Just like if we had 6 and 7, we say 42, or 6 and 7. So I'll take this value, x plus h plus 2, like that. And then I take x plus 2, like that. So this, when you divide by that, you get this. So it will be this, x plus 2. Now multiply by that. We are just doing just the way you could do with the fractions, like that. Then from there, guys, we say this divided by x plus 2, we shall be left with this, then we multiply by that. So this one will be minus, and remember to put a bracket, guys. So this one will be, we are dividing this by this one will get that, plus h plus 2, now multiply by, we now multiply by x minus 1 here, x minus 1, like that. So guys, we can bring it up here. So now we shall have this is equals to, we are now dealing with the first one. So you can draw a line there. So now, guys, we come and say, we do this first numerator, that is x multiplied by x, we get x squared. X multiplied by h, you get plus hx. X multiplied by negative 1, you get negative x. We continue. Now we come to 2. 2 multiplied by x is plus 2x. 2 multiplied by h is plus 2h. 2 multiplied by negative 1 is negative 2. Now we go to this other one here, noting that we have a minus here. So we shall be changing, if in case we multiply x multiplied by x in the x squared, we shall have now minus x squared. So please note the negative, because the negative will be changing the signs after you multiply that. Whatever you get, you have to change the sign. So you shall have x multiplied by x is that. X multiplied by negative 1, we shall have negative x. So now it will be positive x. X, now we have dealt with x, we come to h. H multiplied by x is plus hx. So it is minus hx, like that. H multiplied by negative 1 is negative h, so it will be plus h. So we are changing that because of this negative. Then we come here to 2. Then it will be 2x, which is now minus 2x there. And finally, we shall have minus 2, which is now plus 2. I can write it just there above, like that. So guys, that is our numerator for that. Let's go to our denominator here. Multiply x and x, you shall have x squared. X and 2, you shall have 2x, like that. And then multiply h and x, we shall have plus hx, then multiply h and 2, we shall have plus 2h, then you shall have 2 and x is 2x, 2 and 2 is 4. So that's how we have gotten, guys. And now, guys, we come and try to simplify the question, remembering that we still have our h here, which we are going to divide this. So let's see those things, those terms that can be cancelled and those that can be added together. So you have this x, this one I can cancel because this plus, this minus. Then I have plus hx, I can cancel, and this is minus. Then we have minus x plus x, I can cancel that. Then you have 2x, I can cancel this and this. Then we are left here by, okay, negative 2 can cancel this plus 2, like that. And what are we left with? We are left with 2h and h. So guys, we are going to have now, because already we have cancelled, this 2x is cancelled, this is 2 is cancelled. So what we are left at the top is actually 2h plus h, that is 3h. That is what we are left with on the numerator. All over, now we do this one. This one will be x squared. You have x squared there, guys, like that. Then we have 2x plus 2x is 4x. And then we have plus 4. And still, guys, we have plus here hx. Let me check. Hx plus 2h. Hx plus 2h. So that is all, guys, that we have. So from there, guys, we come and now use our denominator here. We are going to write this all over h. And this one can be written as 1 over h, like that. So we can now cancel this h. So once we cancel that h, we will write here fx equals to limit as h tends to 0. We shall now have 3h all over, actually the h is already cancelled, x squared plus 4x plus 4 plus hx plus 2h. So guys, we are going now to neglect all the terms with the h, because we know that h tends to 0. So this is going to be neglected and this is going to be neglected. So finally, guys, we shall have, let me write here, f of x, that is derivative, first derivative of x, limit as h tends to 0. Then we shall have 3 all over, now x squared plus 4x plus 4 is actually a complete square of x plus 2, x plus 2, like that. So guys, this is then our answer for that. And then guys, I can go to the next question, which is here. I had already done it, and this is how it goes about, guys. Here we have y is equals to e raised to 2x. So we apply this formula now, guys, for our e raised to 2x. And so we shall have, for the first one, we have e raised to 2, then you have x plus h. So you need to make sure that, guys, we are not adding 2x plus h, or we are not adding h to 2x. We are adding h to x, and that's why I have written 2 into bracket x plus h. Otherwise, if you write like this, guys, 2x plus h, that is incorrect. So you have to write like this, 2 into bracket x plus h. Then minus, this is now where we now have the original value. The original value is e raised to 2x all over the h. That is, this is our h. So guys, I hope you understand that the mistake one can make is whereby you add like this, 2x plus h. You are supposed to add 2 and then x plus h. From there, guys, we come and now say f prime x equals to limit as h tends to 0. Now here, e, then you can expand this. If you expand, you multiply 2 multiplied by x, 2 multiplied by h. And this is what now, guys, you get. Minus the original, which is 2x. By use of indices, guys, now we can come and separate this so that we have e raised to 2x and then e raised to 2h. That is on multiplication of indices. That's how we separate it. We use the indices because this one, if you multiply, it will be e raised to 2x plus 2h, which is like this. Then from there, guys, I can come and factor out e raised to 2x, and this is what I have done here. After factoring out e raised to 2x, then you are left with e raised to 2h minus 1 all over h. Now, by use of the exponential series, e raised to x series, this is the e raised to x series, we can now come and fix our series here. So when we fix our series, this is what we find out. Our x for our series here is actually 2h. So it is the 2h we are going now to replace. Where we have x, we put 2h. So as we continue, and as the h tends to 0, we do not need these values, other values. So we just put our first value, that is 1 plus 2h. And this is what I have put here. Then you have this minus 1, we write it there. And originally we had 1 here. And this one was actually this. This is the one now that is here. 1 plus 2h now. Minus 1. So 1 can cancel this 1. And finally we are left with this. E raised to 2x and then 2h. Because now this one is going to cancel that one, we are left with the 2h. The h can cancel, then we are finally left with the 2. So now, as the h tends to 0, this is now the answer we are going to get, guys. And so, guys, thank you for listening to me. Bye-bye.